Hey everybody, welcome back. This is part 2 of the series of minting and creating tokens and NFTs. In this video, we're going to learn how to do that in JavaScript. So as always, my name is Josh, and this channel's mission is to accelerate the road transition to blockchain technology. And an overview of this video, we're going to create a React app. We're going to learn how to create your own token and NFT using the React app that we're developing, and we'll also learn how to send SOL tokens. The code that we'll be writing here will be exactly the same as my previous video, where we use the command line to create our tokens and such. And just like in the last video, we'll be going through the code snippets that's mentioned up here in the link. And as always, what we will not learn, just like in last video, we're not going to learn how to set up a name for our token and add it to a DEX and provide liquidity and so on and so forth. If you're curious about that, I'm sure there are tons of other videos you can watch. And as always, this video is sponsored by this handsome dude. There's not many prerequisite videos to watch. The only one that you might be interested in watching is the part 1 of this video. So outside of that, we can get started. But before we get started, disclaimer, not development advice. I'm sure at this point, you got it. No one cares. Let's move on. So the first thing we need to do, we need to create a React project. Nowadays, we can rely on these starter template projects like starter React project. So prerequisites, we need to have node or /npm installed. I'm sure we can all figure this out. And then we just need to run these 3 commands, npx create react app. We don't actually need to install. That's the nice thing about this. It's just the command will ask to install for us if we don't have it. We'll create it, we'll add the name of our folder, which will just be token. And then of course, we want to write the newest and greatest. We want our code to be written in TypeScript and not JavaScript. Who touches that? Now create a folder for us, and we can just go navigate to the folder and then run npm start. One thing I will note is that if you had problems trying to run the npx command, saying something about version outdated, and if you try uninstalling your create react app and that still doesn't work, try running the npx clear npx cache command, and that's what helped solve my problem. So let's quickly get a project set up. So here's my command prompt. I'm going to go to my WSL instance. In this video, actually, you don't really need to rely on WSL, but since I've always been using it like this, we'll just continue doing so. And for those unaware, WSL is a Linux environment built into your Windows machine, which is very handy for when we write smart contract code because it's not always supported. I'll just go to my root, and like always, I'm just going to go to my video folder. I'm going to create my project, but if you read in the description below, I will have a GitHub to everything I've typed, so you can just clone that repo and follow along, or you can, also make your project and follow along with me in code. So the first thing is I'm going to run the command npx create react, and this will create a new folder called token where our project exists. All right, it's completed. So now if I just go to cd token. All right, so here's the content of our starter project. If we do npm start the project, and then we'll have this pop up. And so this is the React starter program. It's just very simple, very straightforward, a starter app for React. It has all the setup for us already. We can just edit the code. So now that we have our project set up, let's actually connect to it in your text editor of choice, which in my case is VS Code. So as always, since I'm using a WSL instance, I had to get the WSL extension, remote WSL, which allows me to connect to it. But if you have it on your local machine, you can do this differently. Anyways, so first thing as always, we need to open a new WSL window. So you do that by clicking this little button right here. And then now that we have this, we can just go to open folder, and we'll just go to the name of the folder that we created, which is token, and we'll just click OK. And this will open the project. And so we go to source, we go to app, and we see our React application. Now, if you want a quick recap on React, there's a separate video I made about Phantom Wallet that gave a very brief intro to it, or you can watch other React videos. Doesn't really matter. In this instance, I expect some knowledge of HTML and JavaScript, but outside of that, you don't need to worry about too much if you don't understand the framework. You can always follow along. There's not too much involved. here is the HTML element of our page. And then if I were to edit something, for example, I save it, and I go back to the application, you can quickly see that my browser already reloaded the application with my edits. So that's one of the cool things about working in the front end. Now that we have our environment set up and our project set up, let's look at what we need to do. All right, so first thing we need to do is we need to include our library dependencies in our package.json. So for those of you who aren't familiar these days, we use something called npm, Node Package Manager, to handle our dependencies for our library. And the package.json is essentially where we define third-party libraries that we want to use inside our project. So there'll be 3 libraries that we need: the Solana SPO token, which is the Solana Program Library that we're going to use to create tokens and NFTs. We're going to use the Solana Web3 JavaScript library, which is how we actually talk to the Solana servers. And finally, we need to include Buffer. Buffer is a data encoding library. The really only reason why we are including this is because for some reason, and I don't know why, there are problems in the actual code where Buffer is missing. So we had to include the package and then set it and define it so our code does not crash. After we include all this in our package.json, we just run npm install, and then we have everything we need. Okay, so back in here, I'm gonna make this a bit bigger for us. So in our application that we open up, all we need to do is go to this package.json file. And we just need to include the 3 files that we've mentioned. I'm going to do this in alphabetical order. Right, so that's that. Now, if we hit the control apostrophe, or we go to view in the terminal right here, we open up our terminal and we just type npm install, and that'll install our dependencies. All right, done. So nothing too involved. We're going to get to the fun part soon. So in this video, we're going to have 3 project goals. And project goal number 1, we want to mint and send tokens. This is very similar to what we did in the previous video. The only difference is that this time we're actually be writing JavaScript code. So it's very important to note that this will actually be run directly on your front end. So this could be set up for a lot of abuse if done improperly versus like on the back end, because it's so much easier to spoof and mess with the data in the front end than it is the back end, in my personal opinion. So we're not going to do anything fancy. We're just going to create 4 buttons, and each of the buttons will do these 4 things that we mentioned above. So the first button will create a new token and account. You can watch the previous video to learn more about this, but so when you create a new token, you're going to get an address that's associated with the token, but that address itself does not actually store the token. That's what we need to create in our account. So we're going to write a code that whenever we click the button, we'll just create a new token, and we'll create an account that will hold the token. The second button we're going to do is we're going to mint the token to the account that we created. So, just generate more coins. In the third button, we're going to learn how to check the supply of the token and account. And finally, the fourth button, we're going to learn how to actually send some tokens to my specific Phantom wallet. Now, as you can imagine, you can easily set up the Phantom wallet adapter that we talked about in a previous video to let users use their connect their Phantom wallet to this app, and then you can send your tokens to their wallet. So that's pretty cool. Now, let me know if you want to see a video like that. Before we get started, I just want to give a quick note to this note up here. Essentially, a lot of the get functions that we're writing to get the data of our token accounts in both our JavaScript and our command line and maybe eventually our REST code, there's actually a equivalent JSON RPC that's actually being fired underneath. And so you can see what those are up here. Of course, I'm not gonna scroll over it, but if you're curious, you can check it out. I included in the description below. So with that out of the way, let's get started. The first thing we need to do is we're going to create the React front end. So this will be a great React lesson along with a JavaScript lesson. Don't worry about too much about the code. I'll explain it as we go, instead of breaking it down inside this PowerPoint presentation. However, if you prefer the old style, do let me know and I can go back to it. All right, back in our project. So right now we have this. I'm going to give some space. Probably just move all this down. So we don't really need all of this content right here. So I'll just delete all of this, and I'll just keep the header and the div container. We don't really need either of these. And so what we're going to do is, instead of just writing over our code here, we're actually going to create a separate component for each of our project. So for our first component, we're going to create this mint token because in the first project, we're going to learn how to mint a token in JavaScript or React, but same thing. So I'll just hit Control N, create a new file. I'll just hit Control S, and I'll just call this mint token.tsx. TSX is the TypeScript version of a React component. Don't worry too much. And in here, I'm just going to copy and paste the existing app. I'll get rid of the import for the CSS because we don't need to worry about that. And then inside our return, so a quick recap of React is React works by defining our own HTML elements, essentially. So kind of like defining our own div. Right now, this app, for example, is a app component. So for example, that can be represented like this. So for each of the project, we're going to be creating its own HTML element to handle the logic that we want to do. Mint token, we're going to create this. We're writing a function that would essentially return a React component. And don't worry too much about how this works. This is something that React handles. And you might be wondering, how is it possible that React allows us to actually write these elements, these HTML elements in JavaScript code? Because as you know, this is all JavaScript, or TypeScript specifically. And the reason for that is that's what the X is. React essentially has its own type interpretation, and which actually allows the HTML element or something along the lines of that. But don't worry too much about that. We're writing a function that returns an HTML element. So we're going to create a div, and then we're going to create 4 buttons. So now that we define our function that would create our React component, we export our function, specifically just making it available for those who are importing this library or this class. So we go back to our app, and we just do import. And we import the mint token component that we just created. And then, well, first, let's convert this back into a 4 tab space. One more. Now we can create this mint token component. But I imported wrong. So this is the correct import. Okay, so now we are just using the mint token component that we just created. First, I open up my terminal again, and I do npm start. I think if I just move this down, is it still run? Okay, great, it's still running. Okay, well, I don't know what is stopping it, but that's fine. I'm just gonna run it in a different localhost. Now we're running this on port 3001. All right, cool. So now we have our component that has the 4 buttons. Right now, if we click on it, nothing really happens, so that's fine. One thing I do want to actually add is I want to go back here, and I actually want to include a section name. So I'll do mint token section, and I will wrap all the buttons in another div so that we can have better spacing. Compiling. Okay, there we go. Okay, so now we have the mint token section. We know what buttons these are from, and we have the actual buttons. Great. So now that we have these 4 buttons, we can now implement functions to learn how we can actually interact with tokens on the front end. So the first thing we want to do is we want to create a token, and we'll create an account that we use to store all the tokens that we generate, or mint specifically. So back in our code, I'm going to move this down out of the way for us. First, I'm going to import everything that we're going to use in this file. Don't worry, we'll get to it eventually. This will all be included in the GitHub project and description, so just open it up and you can copy and paste this, or you can just type it in yourself. It's great practice. Okay, so the first thing that we need to include is our mint token function. Essentially, what we want to do is we want to create a on-click function for each of our buttons, and that is just code that we execute when our button gets clicked. So for our first one, we're going to use something called, so here's create token, just I paste it just to save our time. We have a lot of red, and that's because we are actually missing some code. And I'm going to add them as we go along. So the first thing we're going to be missing is our connection. This is our connection to the Solana network. So I'll paste that over here. So as you can see, connection is a object from the Solana library that we use to connect to talk to the validator node. And we are talking direct to DevNet. Just like in the previous video, we can't talk to our localhost. So we're using DevNet. And then we just give it the status, which we call confirmed. One thing very cool is if you want to learn what the parameters of your object accepts, on VS Code, you can hit F12, and that'll open that'll take you to your reference. That'll take you to the implementation of the code that you're calling. So the constructor for our connection object takes in two things: the endpoint, which is the network that we're connecting to, and the commitment / config files. If you're curious, you can continue digging into it. So that's the first thing we're missing. And the second thing we're missing is this from wallet. This wallet is going to be used to pay for all of the transactions that's going to occur in this video. So you can, in this, for the sake of this video, since everything is on DevNet, we don't really need to actually use an actual wallet. We can just generate one. So we can call keyPair, which is essentially the wallet, .generate, and this will just give us a random wallet. And we're setting these as constant variables. So these variables I'm defining up here is shared across all of our button clicks. Okay, great. So quickly, so let's kind of go over the code. So the first thing we want to do for our create token is we want to airdrop some SOL into our wallet so we can pay for our future operations. And that is this code right here. We call our connection, and then connection has a lot of functions. And one thing it has is request airdrop. And if you look at request airdrop, it takes in two things: the public key, which is our wallet that we're adding the SOL into, and a LAN port. A LAN port, for those unaware, is essentially the smallest representation of a SOL. I think it's like 1/1 billionth of a SOL. Think of it like Bitcoin in Satoshis. LAN ports is the Satoshi to Solana. Anyways, so from our wallet, we are giving it its public key. And then for the SOL we're giving, we just use we're essentially just using this parameter that is defined, which is 1 billion LAN port, i.e. 1 SOL. It's something we just imported from the Solana library. I wouldn't worry too much about it. So what this code does is we are airdropping 1 SOL into the wallet that we just generated. And as you notice here, there's this await keyword here. All the code here is run asynchronously, so that specifically we need to make a transaction to the network, and then we wait for that network to be completed. We need to use this await function, otherwise we'll just execute the next code before the rest of our code is finished. So we're just saying wait for our airdrop to succeed. We get back, if we open up request airdrop again, is a promise, and specifically a promise of a transaction signature. I will go into promises because that's a whole nother subject. Essentially, for the sake of this video, just ignore the promise and just know that we're getting a transaction signature. And that's what we store inside our from airdrop signature variable. And from there, we just confirm the transactions to make sure we succeed before we move on to the rest of our code. So now that we have that, we can move on to actually mint our token. And from our previous video, we know that a token, or NFT essentially, is just a string of numbers and letters. So we're going to first create our token. And to do that, we'll call this create mint function that is given to us from the SPL token. Now remember, the SPL token library is how we handle creating tokens and NFTs. It's something completely separate from the actual Solana library that we are using to connect to the network. So what parameters do create mint takes in? There's quite a bit more than we have in here, but the 5 things you need to include is the connection, which we already defined, the wallet that is paying for, actually we can just open this up, but the wallet that's paying for the transaction, the authority, the account essentially that's has authority to control the token, which in our instance is just ourselves, the freeze authority, which is who can freeze the account. We just put down nobody, and then decimals. We put a 9 right here, and what decimals are essentially is what is the smallest amount that your new token can represent. So once we call create mint, this will send back, if you look at our code, a public key. And that public key, just like the command line video, if you recall, is the public key of our token. So we're saving that into mint, and this is an error because we're going to use this token across the rest of our onClick function. So I'm just going to save it as another public variable. Okay, great. So now we have our mint. So I just want to print it to our console so we can reference it later when we send it to our Phantom wallet. Otherwise, we have no clue what we're sending. Now that we have created our token, we need to create an account that's associated with the tokens so that we can mint new instances of our token into. And to do that, we have this get or create associated token account. Essentially, what the account that we are creating is called an associated token account because it is the account that is associated with the token. Big surprise. What this function does is it looks at the key pair you give it, and then it finds the account that's associated with the token. And if it doesn't exist, we create one. If so, which means we need to pay for it. So if we look at this definition again, we'll see our 4 parameters. We have the connection, who's paying to initialize, so we have to, the token that we're looking to find the associated account with, and then of course the owner of the account. So we set our connection, our wallet is paying for it, the wallet that we generated is paying for it. We're looking for the mint that we just created, and then we're checking the public key of that wallet. And when all of this is completed, it's going to give us, if you scroll down right here, oh, it doesn't tell us, but it will give us another public key, which is the key to the account that we just created. So I'm just going to also store it up here because this could be referenced later. Now this error goes away, and then we print out the address that we just received, and everything's good. And this is essentially how we create a token and account in our code. No command line involved, just pure code, and thus it can easily scale to any other applications that we want to work with. So let's take a quick look. Oh, actually, one more thing before we move on. There is one little special code that I want to include. Doesn't really make sense, but we have to call this code right here, window.buffer equals whatever exists if it is not null. If it is null, we call our buffer library that we imported, and we set it to be window.buffer. The reason why we need to do this is when I found that I tried to mint a token inside the create mint code, there's a instance where we call the buffer object, and I don't know why. It might be fine in your instance, but in my instance, buffer was undefined. So to get around my problem, I had to define it myself. Actually, besides the buffer, there's actually one more thing we need to do. We created our onClick callback function, but we actually haven't used it yet. So we go to our first button that we've defined. We set the onClick property. These are essentially all HTML elements. Actually, these are HTML elements. And when we click on this button, we want to call the create token function that we just defined up here. Now we hit save, and we go back into our React app. We hit F12, and this will open up our console, our debug console. I went to this console tab right here. Now we just click this button, and if everything works, we will get some logs printed to our console. All right, there you go. All right, so we had an error getting the account. I think it's error 503, so the server's just down. Then let's try again. And this works because in this code, what I did was I set it up so that every time you click the button, we'll just create a new account and a new token, and that's totally fine. Okay, there we go. So we now, in our app, we have a reference to a token, which is 4NN and blah, 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 blah. And that token has an account that's associated, which is ABYF, and blah, 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 blah. So with this information, now we can mint tokens, check the status of our account, and then send it to someone else, which is what we'll talk about next. I just want to give you a quick example of how this flow works. So I'm going to now implement the full thing. So we create the account, the token, and its associated account. Now we need to do the next thing, which is we need to actually mint tokens into our account. To do that, we have another function that we import from the SPL library called mint2. And mint2 takes in a whole bunch of things, but it takes in the connection, the usual stuff, the payer, the person that's paying it, the mint, the token that we're creating more tokens for, the account that we want to mint the token to, and authority is who has the public key of the account that has the permission to even mint the token, i.e. the token creator, and of course the amount of tokens we want to mint, and we can ignore the rest. And what the return type is, we get a signature of the transaction, transaction signature. And no, these are actual transactions that are being made on the DevNet network. So if we take this result, this signature, we can go on the Solana Explorer and look it up for DevNet specifically, and we can actually find the live transaction and follow it. Anyways, so in our mint2, same thing as we've always been doing. We give the connection, the wallet that's paying for it, the token that we're minting, the address that we're sending the token to, and of course the public key of the wallet that created the token, who has the authority. Otherwise, anybody can in theory mint tokens. And in this instance, we're going to mint 10 billion. I was actually wrong. I don't know why I brought decimals, but 9 over here means that 9 zeros is 1 billion. So this basically just means 1 billion is the equivalent of just one token. So when I say 10 billion over here, that's actually 10 tokens that we're minting. And of course, same thing, we get our signature and then we just print it out, and that's mint token. I'll just add it to our onClick. Right, and the next function is the check balance. What all check balance does is it prints out two things. One, how many tokens that we have actually minted into existence that's in circulation, and two, how many token that is in our current account that we have. So like always, we have two SPO functions that we use. Actually, I think get account is from, yep, it's from SPO. Anyways, so get mint, we just give it the connection, and then we give it the public key of the mint that we care about, and it gives us the information back. It is it's a mint object specifically. And there's lots of data in there. One specific parameter that it has is called supply, which tells us how many tokens we've minted into existence. And if we want to get account information, we just call get account, give it the connection and the address of the associated token address that we made that's paired up with our token. And then it'll give us something, it'll give us an account, and inside the account we can just check the amount. So this is just us checking the amount of tokens in an account. Okay, so that's check balance. Nothing too fancy. You can imagine this code being used somehow to check your account balance or check something about your mint. Lots of powerful things we can do. So hopefully I think you're kind of seeing a pattern how relatively straightforward it is. A lot of this code, essentially we just define a function, we make some sort of network request to the SPL library, and then you just check and make sure that the result's successful, and that's about it. Okay, and then the final one is we want to send some of the tokens that we created. I define another function called send token. So for the sake of this video, we're going to keep it simple, and we're just going to send some token into my personal Phantom wallet. The first thing is, just like if you recall from our other video, we need to create an account that can hold the token that we just created. So we need to call the same get or create associated token account function to essentially create a account for the wallet, which is my Phantom wallet, to hold the token that we just generated. So as you see, we have this toWallet variable that's also not defined, and I will just Go back up here. I'll define toWallet. We were just creating a new public key, and then we just give it the public key address. So let's go back to this app. I have my Phantom Wallet over here. I'll just type in my password. And just like always, make sure that if you click on this cog setting, you go to change network and make sure that you're on DevNet. Otherwise, you won't see anything happen. The address is still the same, so data will still be sent over to your wallet. You'll just not see it happen. Right, so I copy my wallet. I go to my code, and I just paste it. But yeah, so now back in our code, we go to send token. We can see right here that we're just doing the same thing as we've done before. We give our connection. We give the wallet that's paying for this transaction. We're giving the token that we want to create the account with. And then I give the wallet that we are creating the account for. And just like before, we get the account public key that we just created. So now we want to transfer the token. We call another function that SPL gives us called transfer. And transfer takes in a lot of things. It has these 6 parameters. And we look at it quickly. It's the same usual things. The connection to the network, who's paying for it, who's paying for the transaction, the source, which is the person that's sending the token, who is the destination, the public key of the source that we're sending. So no, not anyone can just willy-nilly send my token to someone else. And then finally, the number of tokens we want to send. And remember, because we defined 9 up here, 1 full token is 1 billion. So we're essentially sending 1 billion of the 10 billion tokens that we have minted. And of course, we get another transaction signature that we can check on Solana Explorer to see the funds being moved. All right, so that is our last function. We go back to onClick, and we called it send token. And that should be it for this code. Now, if we go back to our code, I'll just refresh this whole page. We get everything fresh. All right, so let's open my Phantom Wallet because we are sending things to myself. I'll just hide all these tokens I've been sending to myself. And so first thing, we're going to create a token. Okay, we have our token in our account. We're going to mint some token. So this is the signature that we can check on the Solana Explorer, who cared. And then we check our balance, and we can see that we've minted 10 billion of our token into our account. And now we're going to send 1 billion of our token to my Phantom Wallet. Hit send token. And that's the account that I've created on my own wallet. And this is the finishing transaction. So if I open my Phantom Wallet, you'll see that I have this new unknown token that starts with EAQ, and we see in our token address, it has an EAQ. So we have now programmatically sent my wallet a one of my token. So that's pretty cool. Before in the previous video, we typed it up, but now we actually wrote code that can handle, in theory, not just my wallet, but anyone's wallet to send tokens automatically. So this can be useful like if you have an NFT game, a social media website, or really any sort of application. So that's it for project 1. Let's move on to project 2. All right, and in part 2, or project number 2, our goal is we want to mint and lock NFTs. Because essentially, all NFTs is they're actually just tokens. And to keep the uniqueness of our token is that we just want to be able to lock it so that we can never mint any more of it. And so it'll be very similar, but let's actually just go through the example. All right, so back in our code, let's just create another React component for our mint NFTs. So, just hit Control-N to create a new file, Control-S, and I'll just call it mintnft.tsx. I'll just put in the same repository. And then, of course, I'll just copy our mint token code, and I'll just call this mint NFT. I'll just change all instance of mint token to mint NFT. Our function here is mint NFT, and I'll hit Control Save. And so let's go into our HTML. The first section is instead of token, we're doing NFT. So this is the mint NFT section. And just paste my answers already like a good student. But we're going to have 3 buttons. Let's go create NFT, lock NFT, or mint NFT, and then lock NFT. So for now, let's just, I'll just comment these out. Could have done that more intelligently, but that's okay. Okay, and then we go back to our app. Let's do it this way. We'll call it mint NFT, and it was just magically imported for us. Thank you, VS Code. Okay, so now we have this. Let's go back inside our React code, and voila, we have our mint NFT section already. Okay, so let's go and actually implement it. Now back in our mint NFT component, the first thing we want to do is we want to define our create NFT. Well, essentially we'll just get rid of all this code right here. We don't need any of this. We just copy and paste in. Okay, so here's the create NFT code. And like we mentioned earlier, a NFT is essentially the same thing as a token. So creating the NFT is basically the same thing. There's only some small differences. We'll keep all the existing parameters that we've had. Those will be used reoccurringly, so that's fine. We'll just keep it there. The only thing we don't need is a to wallet because in this example, we're not actually sending the NFT. All right, so create NFT. Same thing as we've been doing in the previous React component. We airdrop some SOL into our wallet so we can pay for all the transactions. We wait for that airdrop to succeed before we move on. And then we create our token, or in this instance, our NFT. So it's very important to know that the one thing that is different between an NFT, in theory, and a token is that we put 0 for the number of decimals. So one of this token is exactly one value. There's no decimals. So it's not like what we saw earlier where there was like 1 billion of our token represents actually one full token. Okay, so we make the transaction, we get the NFT account public key, or we get the NFT public key, and we just print that out. And of course, just like how we did it previously, we need to create a account, associated token account, that will hold the NFT that we mint. So that's the first function. Nothing too different. All right, next we have the mint NFT function. So it's just like the previous one, previous examples. We're just minting one of our NFT into our front wallet. And then we just get the signature from our request, and then we just print it out so we can check it if we ever wanted to. And that's it. I won't reiterate myself too much here. And then finally, the last part, the most important part of NFTs is after you create a NFT and you mint however many NFTs you want, you need to be able to lock it and prevent yourself from being able to ever mint anymore. I'm sure your users or the people who are buying your NFT cares greatly about this. Otherwise, the value of the NFT that you're selling to them will drop dramatically. In here, we have a lot of more functions that we need to define. So I'm just going to do the same thing as I did in the previous section. I'll go back to my imports and I'll just copy and paste all the actual imports that we need. Like I mentioned before, it's on the GitHub. Don't worry about it. Or just copy it here. Okay, so back inside the lock NFT function. This has been a little bit different than what we've been doing so far, where we actually explicitly called helper functions that would essentially send a transaction for us, and we just get the receipt. In the lock NFT code, we actually are manually creating the transactions ourselves and then sending it. And if you recall from all of the previous Solana videos about creating transactions, what you really need to do is you need to create a instruction, in which a instruction is essentially just the smallest bit of data that you send to the smart contract so that the smart contract will know what to do with the request that you've made. So what we want to do if we want to curve the inflation of our NFT is we want to essentially get rid of the mint token authority, i.e. We prevent it from being minted. And so to do that, one of our libraries, I think it's our SPL token, has a explicit instruction called the set authority instruction that will help us handle this. So if we look at this instruction, it takes in 4 parameters as if we passed in, right? Yep, 4 parameters. The account, the current authority, the authority type, so this is the new authority that we want to set, and the value of the new account that is the authority of the token, which if we pass in null, that means no one's authority of it, which means no one can mint anymore. So we create our transaction, and then we just send the transaction, and that should be it. That is how we lock our NFT. Essentially, we are just setting the authority where we first set up in our mint2, because if you look at our mint2, we can see that the authority is our 5th variable. So our 5th variable, our authority is from wallet. But what we're saying essentially here is that our authority is no longer our wallet. It is nobody. So no one can mint anymore. And that's it. So let's save and let's go back to our example. All right, let's try again. We open up our console. We create NFT. Okay, here's our NFT and here's the account that's associated with it. Now we just mint our NFT. So now we mint. And the important part now is if we lock our NFT. Okay, there you go. So our lock has succeeded. So now the important part is if we try to mint again, we'll get an error. Yep, see right here, we have a custom error. Would have been nice if it actually told us that it was locked. So now we know that's how we lock NFT in JavaScript. Quite frankly, I really don't know why you might want to do this in JavaScript in a production environment, but you know what? I'm not very imaginative, so if you have an idea, leave it in the comments below. I'd be very curious to know why we might want to try and do something like this. And that's it for working with NFTs. All right, and finally, project number 3, just like in the previous CLI video, we're going to learn how to wrap and send Solana. The 3 buttons that we're going to implement, we're going to learn how to wrap the SOL in our wallet to be something called wrap SOL, WSOL. We're going to learn how to unwrap it, and then we're going to learn how to send it to a phantom wallet. So let's get started. So I think we've done this enough now to know roughly what we need to do. Again, so once again, make a new file. Save it. I'll call it send sol.tsx. This is our new component that we're going to include. I'll just copy and paste. I'll get rid of all the helper functions that we've implemented. And we'll replace all of the mint NFT with send sol. That's the function that creates our component, and we are exporting it. And of course, let's just do this more intelligently. And comment out all of our onClick function. Okay, great. We have this. We'll go back to our app, and we'll just create the send-sol, or we'll use the send-sol component that we just created. And that will render it, as you can see over here. We just need to rename some stuff. This is the send-sol section. And let's try this again. That was unnecessary. All right, do it properly this time. Now let's comment out all of this. Now we go back in. Now we see the correct console section. And so that's our front end. Now we need to implement the functions for each of our buttons. Well, the first thing is we want to make sure we're using the right imports. So back inside import, just import everything we're going to use. Of course, just get it from the GitHub repo or just copy. Outside of that, the first thing we want to do is we want to learn how to wrap a Solana. This is actually quite involved. It's our first function, so this will be the hardest part. We want to wrap Solana. We're going to do kind of the same thing we wanted to do earlier. The only big difference between what we've been doing in the past is that instead of creating a token, the token already exists, and we just want to convert our SOL into a wrap SOL. And so just like before, we have our from wallet. Our from wallet will be the person that's paying for everything. So of course, as always, we need to airdrop some SOL into it. We gave it 2 SOL this time because we need to both pay the transaction fee and convert something. Make sure that that transaction succeeded. So next up, this is probably another way we could have created our associated token account. But in this example, the documentation did it differently. So we're just going with it. But we're getting the associated token account that's associated with our wrap SOL. which in this instance shouldn't exist. So I don't actually know what to return. Probably should have printed that out. Actually, we can. So let's do that because I'm actually curious. I also define what this type actually is. It's just a public key. Let's get rid of all of this. We don't need any of this. And to get the address to get human readable string, we just need to convert our public key to a base 58. To get the account, all we need to give is our token address and then the key of the account that we're checking. And so what we have here is this constant called native mint. And if we look at the definition, native mint is the address of the wrapped SOL, essentially. So instead of us creating a token and getting that account address and using that everywhere, wrapped SOL is an actual token that exists already. So this is just the address to it. If you looked at the previous video, we saw something that was like SOL 1111111, something like that. That is this address that we're using. Anyways, so that's the token account. My suspicion when we first run it is that it will be null or something and probably not exist. And then what we're going to do is we're going to create a account. And just like before, instead of calling a function that the SPL library provided for us, we create a transaction and we just define a instruction. And specifically this instruction is just create the account. So we look at this, there's 4 types. We will send it, the person's paying for it, the associated token account. I guess maybe when we first retrieved it up here, it actually was something. It might just exist because this is an actual token. I don't know. The public key, which is the owner. So who is the owner of this new account that we're creating? And of course, the token that we're creating the account for, which is the wrapped SOL. So we create this transaction, we include the instruction, and then we send it to the Solana network. So now that we've created a account for the wrapped SOL, I guess, for our front wallet, now we can actually interact with it. And just like before, we're also creating another transaction. And so in our transaction, we create a system program. In Solana, the validator nodes, there actually are some actual other custom code that is written that's in the network, and system program is one of them. And specifically, if my understanding of it is correct, it has specific functionalities. One of them is transferring. Here are the functionalities, by the way, but transfer SOL, specifically from SOL, normal SOL into wrapped SOL. And so what this function, the transfer instruction, takes in is the public key of the account that we're transferring, the account that we're transferring the value to, which is the the wrapped SOL associated account, and of course the LAMP port that we are, or the SOL specifically that we're converting. And so in this case, I put in 1 billion, i.e. 1 SOL. And then of course there's this create sync native instruction. Not too familiar with it, but it's just to keep sync of the values of the Solana, especially if it's like very small amounts between your wallet and the other wallet. I wouldn't worry too much about it. It's just something to include. And okay, so now we have our transaction. We send it as normal. And then if we want to check on the status of our account, which is what the example did, we can get call the get account, give it the pub key of the token account that we created, and that'll give us an actual account object that we can parse and print out its value to see what is inside of our token account. Remember, this is the account on our front wallet that's associated with our wrapped SOL token. This is real money that we're working with. If this was an application on the mainnet. Okay, so that is Sensol or wrapped SOL. Hopefully not. No, this is a bit more complicated, but not too horrible. So luckily for us, the rest is slightly simpler. If we want to unwrap our SOL, we are using our connection. This is just for printing, but we call get balance to see how much SOL we had before we unwrap it. And then we have another function called close account, which is from the SPL library. Essentially, all it does, if you look at documentation, is it closes a token account. And of course, it returns the value. So we go back here, we give it these 5 fields. In these 5 fields is usual connection, payer, the account that we're closing, who gets the amount, the remaining balance of the closed account. It could be, it could be someone else. You can just, completely send it to a random address and throw it away, and so on and so forth. And of course, you're giving it the authority of the account that we're closing. So no one can just randomly close my accounts in my wallet. So that's these fields. And of course, just like we did earlier, after we actually fired this transaction and run the command, finally, we do the same get balance code again to ensure that we are moving our wrapped SOL, or the SOL from our wrapped SOL account back into our normal wallet. Okay, so that's unwrap. And finally, the last part is the part that's probably we care most about. That's sending. How do we get our money? Just like before, this is exactly the same as our mint token code right here, the send token. We airdrop some SOL into our from wallet just in case we run out of funds to use. We wait for the transaction to succeed, and then we need to include our public key. Copy this. Remember, I already sent one SOL to myself, so I'll just include the key here. And okay, and just like before, we need to get the associated account from our wallet, the wrapped SOL account specifically, so we can transfer that amount. So we call this function. That gets us the public key to our account, from the from wallet. We need to get the associated token account to the Phantom wallet. And so in this instance, if it doesn't exist, it will create a account for us. In my case, in my Phantom wallet, as you can see, it already exists, so it won't. I don't need to actually pay any fees to do this. I'll just grab it. So that's my Phantom wallet's associated token account. And then finally, we just call the transfer, which I won't go over again. It's the same thing as our mint token, but we transfer the token and we want to give 1 Solana's worth. And of course, as the function finishes, we get a signature, which we can check on the Solana Explorer, but that's about it. So we go back here, uncomment our send SOL button, and let's try it out. And just for precaution, I'll refresh. Open up my console tool. Right. Okay. So first, let's wrap our SOL. That says transaction, and we sent 1 million. Now, if we unwrap it, you can see that before in this from wallet, I think this is almost 1 SOL, and now we're back to 2 SOLs. And just to verify that we can send it again, we'll wrap it again. There's a transaction, and this is how many SOL is inside that the associated account that we've created. And then finally, we just hit send SOL, and there's the transfer address. And if we look up inside my Phantom wallet, we can see now I have 2 wrapped SOL. And that's it. We're done with project number 3. All right, just to recap, in this video, we had 3 projects. We learned how to mint and send tokens. We learned how to mint and lock NFTs. And finally, we learned how to wrap and send wrapped SOL across the network. And all of this is done via JavaScript on the front end of our code. No smart contracts involved. Well, there is a smart contract, but just not smart contracts that we implemented. So hopefully this video has been helpful and get the juices in your brain working, and maybe you get some new app ideas. In the next set of videos, I'll be working on using these same set of functions inside a smart contract. So that'll be interesting to see how that plays out. If you found this video helpful, I greatly appreciate a like and subscribe. Otherwise, until then, look forward to my next video, and I'll publish it when I get there. But until then, I'll see you all later.